So here we shall explain the concept of the second derivative test for finding the local maxima and local minima of a function. So let f be a function defined on, let f be a function defined on an interval I, and c, let a number c belongs to that interval I, and also let the function f be twice differentiable at x equal to c, be twice differentiable at x equal to c. Then the first rule is that x equal to c is a point of local maxima. X equal to c is a point of local maxima if f dash c, that is equal to 0, and f double dash c, it means the second derivative of the function f of x at x equal to c, is less than 0. And then also the value of the function at c, it means f of c, is called the local maximum value of the function f. Local maximum value of the function f. And then the second rule is x equal to c is a point of local minima. X equal to c is a point of local minima if f dash c, that is equal to 0, it means the first derivative of the function at x equal to c, that is equal to 0, and f double dash c means the second derivative of the function at x equal to c, that is greater than 0. In this, so then, and the value of the function at x equal to c is called the local minimum value of the function f. Local minimum value of the function f. And then, so then the second derivative test fails. So the second derivative test fails if f dash c, that is equal to 0, and f double dash c, that is also equal to 0. So if f double dash c is also equal to 0, then we use the first derivative test. Then we use the first derivative test only. Use the first derivative test to find if the point x equal to c is a point of local maxima or local minima or point of inflection. Local maxima or local minima or point of inflection. Or point of inflection. Okay. Then so based on, so here we can see that if the slope of any function, suppose local minima will be somewhere here. So here we can see that the slope of the function at x equal to c, suppose it is a graph of some function f of y equal to f of x. So at x equal to c, the slope of the function is 0. It means f dash c will be equal to 0. And here we can see that the slope is changing from negative to positive. So it means that the slope f dash x is increasing. F dash x is increasing from negative value to positive value. So I can say that the rate of change of slope, which is f double dash c, that should be greater than 0. It means the slope is increasing, since the slope is increasing from negative to positive value. So if f dash x, f dash c is 0 and f double dash c is greater than 0, then x equal to c will be called a point of, local minima of the function f. And then suppose if we have a graph, suppose like this. So this is the graph of x, y equal to f of x. So then at some point x equal to c, the slope is 0 here. It means f dash c is 0. And the slope of the tangent to the function, which is f dash x, that is increasing from, that is actually decreasing from some positive value to some negative value. Here we are having negative slope, and here we are having positive slope. So the slope decreases. So it means f dash x is decreasing. Here f dash x is decreasing from the positive value to some negative value as x increases through c. So therefore, if f dash c that is equal to 0 and f double dash c that is less than 0, if double dash c is less than 0, it means that the slope, the rate of change of slope is negative. It means that the slope, since the slope is decreasing from positive value to some negative value, that is why we should say that the second derivative means f double dash at c that is less than 0. So if these two conditions are true, means if f dash c is equal to 0 and f double dash c is less than 0, then only we can say that x equal to c is a point of local maxima of the function f. Maxima of the function f. And in case of point of inflection, we know that if it is, the graph is suppose somewhat like this, then here at this point at x equal to c, the slope is 0. It means f dash c is 0. And the slope is not changing its sign. It means the slope, so here if double dash c that is equal to 0, it can happen only if there is point of inflection. It means that the slope is not changing. So hope you have understood the concept. So we shall also explain this second derivative test with the help of some examples in the subsequent videos. Thank you.